Devices used to make your work easy are machines. So ICSE, this is specifically for you. Machines is what we are going to do today. So welcome to Science Arena. I am Monica. Let's see what machines are. So let us define what a machine is. A machine is a device. What kind of device? Which is either used to overcome large resistive forces. In large resistive forces को क्या बोलते हैं हम? Well, they are called the load. And these large resistive forces are being overcome by applying smaller input forces called effort. And this effort is being applied at a convenient point in a desirable direction, right? Or this machine can also be used to obtain a gain in speed. So there are certain outcomes from this very definition which we can write as the functions of machine. So देखते हैं functions of a machine इसी definition से बना है. So there are certain highlighted terms here which you need to incorporate in your definition about the functions of a machine. So a machine can be used as a force multiplier. That means I have been lifting heavier loads by applying smaller input effort. So that's what is being called as a force multiplier. Larger load with smaller input effort. If not as a force multiplier, then perhaps it is being used as a speed multiplier. That means I am doing my work faster. So there is an advantage of speed perhaps when I am using a machine. So that's the second function wherein I am using my machine as a speed multiplier. Oh, I could have that convenience of the point of application of force. So for instance, if I take the example of our bicycle. So if you want to ride the bicycle with two wheels, its body, just by application of a force on the pedal, we are going to move the entire bicycle. So that is what is called as the convenience of the point of application of force. And what about lifting a heavy bucket? So if you want to lift a heavy bucket against gravity, well, it needs a lot of effort. So if you want to make your work easier, what do? Well, you can use a pulley. So if you want to lift that bucket against gravity, you just need to pull it by means of a rope in the direction of the pull of gravity. So that is what is called the convenience of the direction of effort. So these are some of the functions of a machine. Now some very important terms related to your machines. Load. Load is that resistive opposing force which has to be overcome by a machine. And what is effort? Well, effort is that force which is applied on this machine to overcome that resistive force load. Right? अब इस लोड और एफर्ट के बीच का relationship is called mechanical advantage. So what is mechanical advantage of a machine? Well, it is a ratio between load to effort. So if it is a ratio between two similar quantities, well, mechanical advantage has no units. So mechanical advantage has no units because it is a ratio between similar quantities. अब ये mechanical ratio कैसे impact करता है? पहले इस ratio को लिख लेते हैं हम. All right. So let us write that down. We just said that mechanical advantage is load by effort. So what happens if my load is bigger than my effort? So load bigger than effort means what? My fraction becomes greater than 1. If your numerator is greater than the denominator, I end up getting a fraction which is bigger than 1, isn't it? Now, what happens if my load being lifted is more than the effort being applied? Well, I have used this machine as a force multiplier, right? So this is the condition for the machine being used as a force multiplier. If I have a mechanical advantage greater than 1, well, my machine is a force multiplier. And what if my mechanical advantage has the load lesser than the effort I have put in? In that particular case, my mechanical advantage becomes lesser than 1. So if my mechanical advantage is lesser than 1, what do I get? Well, it is perhaps a speed multiplier. Alright, because I am certainly not getting that advantage of gain in force, but of course there is a possibility that I am getting an advantage of speed here. Alright, now what if my mechanical advantage is 1? Well, I have no gain whatsoever. So perhaps this may be a condition wherein I am still using this machine because I have an advantage of the application of effort in a convenient direction. So these are some of the cases which we are going to talk about as we proceed. Another ratio here, the velocity ratio. What is velocity ratio? Well, the ratio of the velocity of effort to the velocity of load is velocity ratio. अब ये velocity of effort to velocity of load क्या होता है? Okay, so if I say velocity ratio is velocity of effort by velocity of load. So basically displacement of effort per unit time to displacement of load per unit time. Time तो cancel हो गया. So what do we have? Displacement of effort to displacement of load is what we are talking about. So I can very well say that my velocity ratio is also equal to distance moved by effort to distance moved by the load. Well, now that we know it is a ratio of similar quantities, velocity ratio के पास भी कोई unit नहीं है. It is a unitless quantity. Yes. So अब हम बात करने वाले हैं efficiency of a machine की, क्योंकि mechanical advantage and velocity ratio are going to help us calculate the efficiency of a machine. So are all machines 100% efficient? Well, ideally they may be, but practically none of the machines are 100% efficient. Let's see why they are not 100% efficient. What is efficiency of a machine? So it is the ratio of output work to input work. So output work is basically being referred to as the work done at the load end, and the input work done is done at the effort end. So whenever we are talking about work done is nothing but force into displacement. So let us relate efficiency to output work to the input work. And how can we write this? Efficiency is equal to output work done by input work done. That means since work done is equal to force into displacement, let me write it as, in that particular case, what will be output work done? We are talking about load as the force and displacement of load as the displacement here, right? And what about the input work done? Well, the input work done is in the form of the effort as the force and the displacement of effort as the displacement. Now, if you look at this ratio, since L by E is mechanical advantage and velocity ratio is given by the distance moved by effort to distance moved by load. So what can we do here? This part can be written as mechanical advantage. And what about this part? This is 1 by velocity ratio. Since velocity ratio was dE by dL and this is dL by dE. So my mechanical advantage by velocity ratio gives me my efficiency. I could very well interpret this efficiency as a percentage by multiplying it by 100. So efficiency is equal to mechanical advantage by velocity ratio into 100 as efficiency expressed in percentage. Under ideal conditions, the mechanical advantage of a machine is equal to the velocity ratio. That means I will always end up getting the ratio between mechanical advantage to velocity ratio as 1. But does this actually happen? Well, practically it never happens. Now, why is it that it never happens? This is because of the loss in energy happening in a machine due to reasons like friction which exists between moving parts of the machine. Now the moving parts of machine also are not weightless. They are having weight and they are not perfectly rigid. They wobble, they create noise, right? And these are the reasons wherein the energy input is being lost. Now there are parts of machines which have strings. Now these strings may not be perfectly inelastic. So this effort which we have put in into the machine is now being partly utilized or used up in overcoming these problems. So if that happens, the evident impact is the mechanical advantage now is less than the velocity ratio. So if that happens, my mechanical advantage to velocity ratio is lesser than 1. So if that happens, obviously my practical machine is not going to be 100% efficient, right? Now the fact remains that though the mechanical advantage has changed, the velocity of the ratio of the machine does not change. Why is that? Mechanical advantage being a ratio between load to effort is becoming smaller because now a part of this effort, of the force effort, is being used up to overcome the frictional forces here. Now if that happens, naturally the mechanical advantage changes. But what about the velocity ratio? Now velocity ratio is a ratio between the displacement of effort to displacement of the load. Now these displacements are independent of the friction in the machine, the weight of the moving parts of the machine. They don't depend on these factors, as a result of which the velocity ratio remains unimpacted. So the mechanical advantage has changed, but velocity ratio has not. I hope you have got it all for today, and if you have, please do remember to join me again for more concepts on machines. So we are going to talk about levers, we are going to talk about pulleys. So hope to see you again. Thank you for being here with me today. Bye.